Alright, so we're going to talk about what oxidation and reduction are and how you assign oxidation states to different elements when they're on their own or when they're in a compound. So, first and foremost, oxidation is the loss of electrons and an increase in oxidation state. And we're going to focus on the increase in oxidation state for this first part. Reduction is the gaining of electrons and the decrease in oxidation state. Because if you gain an electron, you've gained something that is negative, so your oxidation number will decrease. In order to assign oxidation numbers, you need to know these 6 rules, and eventually you'll memorize these 6 rules. You won't even have to do it intentionally, you'll probably just end up doing it because you'll work enough of these problems where you'll remember to check these rules off the list. Rule number 1 says any element or diatomic element has an oxidation number of 0. Examples of that would be like sodium, all by itself would have an oxidation number of 0, or chlorine, which is a diatomic element, would have an oxidation number of 0 when it's Cl2. The 2 makes it diatomic. Rule number 2, any ion's oxidation state is the charge on the ion. So, if we have Br with a -1 charge, its oxidation state is -1. Rule number 3, oxygen in a compound is -2, fluorine in a compound is -1. The exception to that rule would be if oxygen is with fluorine or if oxygen is in hydrogen peroxide, so H2O2. Oxygen, when it's in hydrogen peroxide, has only a -1 charge to counteract the positive charge of hydrogen. Alright, rule number 4, hydrogen in a compound is +1 if it's with a nonmetal and -1 if it's with a metal. So that goes back to our H2O2, because oxygen is a nonmetal, hydrogen was +1. Rule number 5, in a compound, group 1, 2, and aluminum are +1, +2, and +3 respectively. So group 1 is +1, group 2 is +2, and aluminum is +3. And the sum of all the oxidation states in a compound must equal the charge on the compound. So, we'll talk about that one and I'll give a little example. So we come to our first compound, NaCl. As I look across the rules, this is not an element on its own, it's a compound. It's not an ion, oxygen isn't in this compound, and hydrogen isn't in this compound. So the next thing we have to worry about is 5. Group 1 metals we come to. Now if you look at a personal periodic table, or any periodic table, sodium is in group 1. Because sodium is in group 1, it has a +1 oxidation number. Because sodium has a +1 oxidation number, and there's no charge on this element, normally a charge would be written here if this compound was charged, because it's not, they just need to cancel each other out. So chlorine has a -1 charge. Moving on, oxygen, O2, is a diatomic element. So any element or diatomic element has an oxidation number of 0. Because oxygen is one of our 7 diatomic molecules, its oxidation number is 0. Next we come to Fe2+. So this is an iron ion. So it is not an element or diatomic element. It is an element, but it is an ion. So this ion rule comes into play. And any ion's oxidation state is just the charge on the ion. So because this iron has a +2 charge, its oxidation number is +2. Okay, now things get a little more complicated as we start to look at multiple elements in a compound. So here we have 3 chlorines in one compound in this aluminum chloride. And so as I look through the rules, it looks like I have a rule specifically for aluminum, and it's that aluminum is always +3. So, +3 for aluminum. Now, this compound does not have a charge. There's no charge written here to indicate that there is, so we know that there is not. So these 3 chlorines have to cancel out this 1 aluminum. So if our chlorine has a -1 charge and we have 3 chlorines, then altogether it will be a -3 charge. Because it is a -3 charge, it nicely cancels out our +3 charge. Once we've determined that that -1 charge is for one single chlorine, we no longer need this top one because we've balanced them out. Alright, next we come to a charged compound. So this is NH4+. NH4+ is one of our polyatomic ions. It's ammonium. So, as I look through the rules, it's not an element on its own. It is an ion, but because oxidation states are always assigned to individual elements, the fact that it's a polyatomic ion doesn't really matter. So, then I'll go through number 3, which is their oxygen, no oxygen or fluorine, hydrogen. Hydrogen in a compound. It's +1 if it's with a non-metal. Well, sodium is above the staircase on the periodic table. Nitrogen, sorry. Nitrogen is above the staircase on the periodic table, which makes it a non-metal. So hydrogen must be +1 since it's bonded to a non-metal. But we have 4 hydrogens. Because we have 4 hydrogens, we need to multiply that by 4. So really it's +4 overall. Now, unlike the previous examples, we don't want to completely cancel this out. We want to leave one positive charge overall. So, what number can you subtract from 4 to end up with just a +1 overall? 3. So our nitrogen has to have a -3 charge. Once we've figured that out, we no longer need this top charge. So our hydrogen's oxidation number is +1, our nitrogen's oxidation number is -3. Last but not least, we have a compound that has 3 elements in it. So it's not an element on its own, it's not an ion, so we move to rule 3, which says that oxygen in a compound is -2. So we put our -2 above the oxygen, but now we have 4 times a -2 is -8 overall. And if you'll note, this compound didn't have a charge written on it, so this is one where we need to cancel everything out. Now here we have hydrogen. Hydrogen has a +1 charge when bonded to nonmetals, so that's +1. But we have 3 hydrogens. So overall, this compound should be +3. So now what we need to do is decide what the charge on phosphorus is, because we know that the charge on hydrogen is +1, the charge on oxygen is -2. The way we're going to determine that is by seeing that we have -8 plus 3 still leaves us with a -5 charge overall. So the way we get rid of that -5 charge is with a +5 charge. So our phosphorus has a +5 charge. Now that we've done all of that work, we no longer need to worry about the +3 or the -8, and those oxidation numbers have been assigned.